Welcome everybody uh, for watching this video. In this lesson, you can learn the basic application of medical uh, imaging classification using deep learning method. Here I show a hands-on process to classify medical image using deep learning in Google Colab. So, in medical imaging for image classification, we need several steps to complete the classification process, and this work we will show the complete process to classify a image. Since, as you know, the Google Colab is most easiest way to run and compile the image analysis system. That's why we use the Colab. And if you had data, any Google Drive, you can easily access through the Python. So that's why we need uh, some uh, library to import and accomplish this operation. Here we use this command to mount the Google Drive options. Once you write this command and compile the cell, then you will get a permission to use your Google Drive. After completing the running, it display drive already mounted at content drive. Once drive is mounted, then you can access all data from your drive. So yeah, after this, we need some header file uh, to accomplish our work. So don't worry, this too much library or header file here. Every header file library is very popular. You can easily search it and find the structure of these ones. So once you understand what library file you required, you can easily use these library functions. In second step, basically, we need to run a generator function. It is also called the load function. That means if you have image in your drive, then you can load that image drive using the image generator. So since, as you know, for deep learning method, we need two data types. One is for training and another one is for test. So that's why we create two generator. One is training generator, another one is test generators. And then we perform the read operation from perform the read operation from this drive. In my Google Drive, the dataset contains actually the research and data folder. So that's why I write here the complete drive path. If you have the uh, drive in different folders, you can change it according to your data. Here also, I have the data is in categorical mode because my data is multiple data, and here multi-class data. That means not two class. I have two more classes. That's why I have written it categorical. Also, in my cases, the data sheet is in uh, 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 RGB modes. That's why I written here the RGB. So once I directly put this code in here, then if I compile the code, I will get this type of message. It's mean I have total 5,712 images for training with 4 different classes and 1,311 images with 4 classes for the test purposes. Then Once your training and test data is ready, then you can model the deep learning models. Here I have used a very simple CNN models with sequential model. I have add a convolution layer, flattened, dense, to dense layer. Since in my cases there are 4 class, that's why I have put here 4 class. If you have 3 class, you can write 3. If you have more than 3, 4, you can write it as your class. You can automatically create as well. I am not going through with this ones. Another one is since my data is categorical, that's why I put here categorical cross entropy. If you have two data set, then you can easily written here the binary cross entropy here. So you need to little bit study what type of loss function of matrix where you can use here. So after creating this model, it times to training your model by using fit function. So in this case, I have used total 15 epochs with my training data and that validation data using the name as test. So when I activate this cell, that's mean when I run this cell, then it takes few more time, but yeah, you can uh, make it more faster by using a little bit tricks. That means go your runtime before starting mounting your drive, and then change the runtime mode with using GPU. Then it will make your processing time more faster than the as usual. So after finishing your training, you will get some loss categorical accuracy and some over some things. So, so now it's time to test the model by using our curating test dataset. Here, one thing, since I have used the uh, training test, I have used the name history 3 as training name model, so that's why I use this history 3 to find the to find and plot the accuracy and loss curve. So this is the basic theory of editing accuracy and plot curve. When I run this cell, then I got this figure. Here the green curve represent the training data and this red curve represent the test. It's very nice curve because it's provided very good accuracy. There is no imbalancing or something. If you get near about 1, then it also provide a good result. But in validation case, if your curve got more than this one, then it will be more best. In my cases, since I don't apply any other processing, that's why my result show this like that way. So you can improve this methodology in your own way. You can also modify the CNN basic CNN model. You can use also transfer learning, whatever it is you want. You can modify this CNN model according to your requirements. So after plotting this curve, I have applied the prediction model to evaluate our basic methodology. For this reason, I have used this prediction function by using this shape model 3, and I also calculate the accuracy score both and the loss score as well as. So here you can see in my these methods I got 96% accuracy with a loss 2.0 for all of the test datasets. So you can use this model in any classification application based on your image. If you have the medical image, then you can apply it for medical image. If you have any COVID image, you can apply it in your COVID image. And if you have any other classification image, then you can apply this one as well. So based on your application, you can rename it and apply this model. And one more thing is you can get this type of help. You can get help from Kaggle as well as TensorFlow, and this site you can search it, so you can got more help from, and you can also got data to download in your applications. So if you have faced any problem or something, you can uh, go through the video again. I think it will be very helpful to you, because this code is uh, since this code is provide very good results, you can directly apply it for your case. Moreover, one more thing, I have attested here a pre-processing steps. That's why in my cases it produced very good results. So this is the well generated pre-processing method. So you can also use this model, reading model directly to in your cases. And if you have any small quantity data, then you can also apply the data augmentation. So that's all for today. If you have any further question or requirement, you can ask to me. Thank